Hello friends, welcome to the second lecture of Monopoly. In this class, we will be doing numericals based on price discrimination. But before doing that, I would love to solve two more numericals for you where there is no price discrimination. After that, we will be doing numericals primarily based on price discrimination. So, let us start. Suppose we have a price function and that price function is 40 minus Q. We also have total cost which is 50 plus Q square. Now suppose I want to solve equilibrium quantity here. In the last lecture I told you that there are two ways to solve equilibrium quantity. One is MR is equal to MC approach and the second approach is you take profit function and you maximize that with respect to quantity. So I'm gonna use MR is equal to MC approach. Now first I'll solve TR which is P into Q. Going by the function 40 minus Q into Q shall be 40Q minus Q square. MR is changing TR with respect to change in quantity, or in other words I am differentiating this TR with respect to quantity, and what I am gonna be left with is 40 minus 2Q. What about MC? Well guys, MC is change in total cost with respect to change in quantity. So I am gonna differentiate this total cost function with respect to quantity and I should be left with 2Q. Now using this MRMC, what I have here is this, and solving it further shall give us quantity as 10. If I want to solve price, not a problem. You have the price function here which is 40 minus Q. Use that. Q is 10, so your price is 30. Now we will be taking on the profits. If I want to solve profits, or if I want to have the value of profits, I'll be going like this. Pi, which is profit, is equal to TR minus TC. Now what is TR? TR from here is 40Q minus Q square minus TC. TC is 50 plus Q square. Now using the values here, 40 into 10 minus 10 square minus 50 plus 10 square, I should be able to get 400 minus 100 minus 50 plus 100. So my profit is going to be 300 minus 150 and my profit shall be 150. So you can solve this numerical in this particular manner. This is quantity, this is price, and this is profits. Now we have one more numerical for you. In this numerical we have Q as 2000 minus 20p and we also have a cost function. Now if you want to solve equilibrium quantity, let me give you one important piece of information here. It is always handy that you convert this function always in terms of price. So this shall look something like this. So now you have this as a price function. Cost function is there. So now if you want to solve quantity, not a problem. Use MR is equal to MC. For that I am first going to solve TR which is P into Q. In this case my TR is going to be 100Q minus Q square upon 20, and that's going to be our TR. Now if this TR, with this TR I can solve my MR, and my MR should be 100 minus Q by 10. I think we are all okay with this. This will be our MR. Now what about MC? Well, we will differentiate this total cost function with respect to quantity to get to MC, and if you see our MC in this case should be this. By differentiating whole of that with respect to Q, you'll be getting this. Now MR is equal to MC, so 100 minus Q by 10 is equal to 0.1 Q. Once you solve it, you will be able to get your quantity as 500. What about the price? Well, price function we have here as 100 minus q by 20, which will be 500 upon 20. So our price in this case should be 75. So guys, now we will be talking about price discrimination. In simple terms, price discrimination refers to charging different prices for the same good. In order to explain price discrimination, you should understand that there are 3 degrees of price discrimination, popularly known as first degree, second degree and third degree discrimination. We shall start with first degree discrimination. Well, first degree discrimination is of 2 types: perfect first degree discrimination and imperfect first degree discrimination. When we talk about perfect first degree discrimination, here the monopolist charges each consumer his or her reservation price. In other words, the monopolist is going to charge each consumer the maximum price which that consumer is willing to pay. Under imperfect competition, things are different. I shall explain this with the help of an example. Suppose profit maximization price happens to be this. Under imperfect first degree discrimination, the monopolist, instead of charging each consumer his or her reservation price, actually creates different categories. For example, this category where he is going to charge P1 and this category where he is going to charge P3. Mind it, P3 shows that the monopolist is not going to charge a price which does not cover its MC. Now, what will be the use? Guys, in reality, perfect first degree discrimination cannot be used properly, because just by looking at the consumer, how would you know what would be his reservation price or the maximum price which the consumer is willing to pay? So instead of using perfect first degree discrimination, in reality, imperfect first degree discrimination is used, where the seller or the monopolist charges different prices but not exactly the reservation price. What he does is have certain categories where according to his judgment he can charge different prices. Popularly, this is done by chartered accountants, popularly known as CAs. It is also done by car dealers, how I shall tell you, and doctors sometimes do this as well. For example, CAs. Well, but just by looking at the books of his client, he can actually charge a different price. He can charge a higher price, say P1, or a profit maximizing price P, or a lower price P3. In the same way, car dealers and doctors may also sometimes use imperfect first degree price discrimination. But the catch is, when you are solving a first degree price discrimination numerical, you are supposed to use perfect first degree price discrimination, where the consumer is actually paying his or her reservation price to the monopolist. How shall we be doing it? We will see it shortly. So now we have one more numerical for you. In this case, we have a price function and MC. If there was no price discrimination, the equilibrium quantity would have been solved through MR is equal to MC. But if the question says that there is a first degree price discrimination happening, then this shall not be used. The approach that shall be used is P is equal to MC. Why? I'll be explaining that as well. First of all, if I'm using P is equal to MC, don't you think equilibrium quantity should be solved like this? So it can also be considered as if we are actually solving a quantity for a competitive market, because there also we use this, which is P is equal to MC. In this case, if you talk about price, you cannot actually tell about the price, because under first degree price discrimination, that too under perfect first degree price discrimination, there is no uniform price which is charged by the seller. So at best we can say first unit price, I repeat, first unit price, that should be 120 minus 2 into 1, 180. Similarly, you can say last unit price. So last unit price should be 120 minus 2 into 20, that should be 80. So here you really cannot have a uniform price. As far as consumer surplus is concerned, in this case it shall be 0. Why? Well, consumer surplus says it is the difference between what the consumer is willing to pay, that is its reservation price, minus what he actually pays. Don't you think in this particular case of ours, the consumer is actually paying his reservation price, thereby he will not have any consumer surplus. What about the dead weight loss? Well, I guess that shall also be 0, because if you see, you will find this quantity which has been produced by the monopolist, or rather sold by the monopolist, is 20 units, which is actually equal to competitive market quantity. So we all know that if the quantity equals competitive market level, there can be no dead weight loss. So now we have one more example. Suppose we've got again a price function and MC as well. So now if there is a first degree price discrimination and we need to solve the quantity, you know that we're going to use P is equal to MC. So 100 minus Q is equal to 20 plus Q, and that shall give us Q as 40. Now the question is, so why we are using P is equal to MC? In the normal scenario we use MR is equal to MC because that is the level where profit is maximized. So what is the rationale here to use P is equal to MC instead of MR is equal to MC? Don't you worry guys, I'll be explaining that with the help of an example. So now I will explain why we take P is equal to MC under first degree discrimination instead of MR is equal to MC. I am taking a tedious example here, so would urge you to be extra careful. P is 150 minus 3Q, MR is 150 minus 6Q. We assume that MC is 5 for first unit and then it increases by 5 for each extra unit. If there is no price discrimination, optimal output occurs where MR is equal to MC. Let's assume that in this case it occurs where the output is 13 units. So thus P would be 111, TR would be 1443, TVC would be 455 and profit would be 988. But the demand curve tells us that the reservation price is different from MR as shown in the table below. So we've taken some quantities, MC as per the question, MR by putting those quantity in the MR function, and the reservation price by putting those quantity in the price function. Now important information. When there is a price discrimination, each customer is charged a price that corresponds to the demand function, so the optimal output occurs when MC curve intersects the demand curve. Now as the demand curve intersects MC curve close to 19 units, that is the optimal quantity. I shall be explaining that with the help of a diagram. Now we will look at the diagram. When it comes to TR, it shall be the price or the sum of the prices. Say in this case, we have seen that the total 19 units have been sold. So each price or each unit price shall give, the summation of that shall give the total revenue. If you total that, you'll get 2280. MC is 950. Profit thus is 1330. It shows that by having perfect price discrimination, a firm earns extra profit of 342. Now, area ka kha ga, that is 0 ka kha ga, shows optimal output in price when there is no price discrimination. You can have a detailed look. Quantity 14. Area ma sa na shows profit when there is no price discrimination. Ma sa na, you can have a look. Whereas area ma sa la shows additional profit with discrimination. In short, the optimal output would occur under perfect first degree discrimination where P is equal to MC. Guys, this example is a bit tricky, but trust me, it is going to be so helpful that it is going to help you in your MA Economics preparation as well. And you won't find this example in any book. So guys, be extra careful. Enjoy this example because it is actually a game changer for you. Thank you.